Alright, so in this video, we're going to be talking about refactoring in Clojure. For me, for a long time, it's been one of my biggest pain points and frustrations. And so a lot of this video comes from me being angry at it and really fighting with it and trying to find a way to make things better. I also hosted the refactoring unsession at ClojureConf, so a lot of the content here comes from the work I did preparing for that session. Now, if you've done any refactoring before, you usually do it inside of your editor. And Clojure developers use all sorts of tools, the most popular being Emacs, Vim, and VS Code. But thankfully, the refactoring tools for all of these editors are mostly the same, thanks to the Language Server Protocol, or LSP. Basically what happened is when Microsoft released VS Code, they also released this protocol that defines some common IDE functionality like code completion and formatting. The idea was that if you made your editing tools conform to this interface, then that interface could be consumed by all of these different editors. So it was great because you had the system where you defined bare-bone editing features for the language of your choice, and then kind of instantly make it available across all platforms. So Clojure has a language server protocol, and it's actually built on top of another tool called clj-kondo. This was actually originally developed as a linter, but it provides a whole bunch of base level functionality, like telling you what functions are defined and where, and kind of like tracing references, and just a whole bunch of stats and info that would be useful for a refactoring tool. This then gets consumed by the Clojure language server protocol, which is itself its own library. And then each of the individual editors have tools that consume Clojure LSP and provide a whole bunch of user-friendly tools and Clojure refactoring features. Although the plan is to give an overview of the whole ecosystem, I'm going to start this video by talking about LSP-mode in Emacs because it's the editor that I use and it's what I'm the most familiar with. Alright, so what's in Clojure LSP? What does it actually let you do? Well, it lets you do the really basic stuff, like click on a function definition and find references. It also lets you rename variables, resolve imports, and generally move stuff around. So basically, when you're trying to change the name of a variable, instead of doing something like a find and replace, you can use reference tracking to track where that variable is actually used and kind of more easily track down the call sites in a whole bunch of different files. And this is really useful because you don't have to think as much about naming conflicts or namespace resolution or all of that jazz. Alright, so now I'm just going to show off some features of LSP mode in Emacs. In order for this to work correctly, you obviously need to have LSP mode installed, as well as the Clojure LSP extension. Something you should be aware of when you go to install this is that some of the Clojure LSP mode bindings get overridden by some of the CIDR bindings. So for things like jump to definition and find references, you might want to double check to make sure that it's not actually bound to the CIDR version of the command. Now with LSP mode and Clojure mode enabled, you'll see these extra details in your editor view that show you how many times the function is used. And you can go ahead and click on this and see where the references to that function are in your code. You'll also get these little highlights for linter warnings and other things that you might want to be aware of. By default, it also has this really ugly breadcrumbs view that you can turn off by disabling it in your Emacs config. Alright, so let's get on to some refactoring. I'm going to start by renaming this variable run web server to a different name. So I'm going to highlight the text, and then I'm going to do emacs-lsp rename, and rename web server to my web server. And you can see that this variable has 3 references, and all 3 of those references were updated when I updated the variable name. Now, I'm just going to revert this back really fast because I don't actually want to rename this. Now, if I go up here to scoring/attach game scores, I can see that I can actually go ahead and rename stuff across files. So if I want to do LSP rename, I can go ahead and rename attach game scores to my attach game scores. And as I can see, it's updated here, and it's also updated in the original file. Now, something that's really, really wonky about the way that LSP mode refactoring works in Emacs is that when LSP mode applies edits, it does not actually save the files that it operated on. So it edited these 2 files, applied some edits to it, but as I can see from the star in the corner, these are both unsaved buffers. And what makes this really confusing is that LSP mode operates on the state of your files that has been saved to disk, and not on the unsaved state that exists in these buffers. So now if I go back and I go ahead and I save this file, but not the other one, the names for attached game scores, the values that are actually saved to disk, are different between the two files. So now if I go back and I try to edit this again, and I do LSP rename, let's say hello attached game scores, then I can see that it edited the value in this file, but it didn't actually edit the value of the other file that I had open. And this is because the files saved to disk actually have different values in them. So according to Clojure LSP, the reference linking this variable name to that function definition no longer exists. This is really frustrating, and basically the moral of the story is if you make edits using LSP mode and you don't save all of your changes as you go along, consecutive edits might not behave in the way that you would expect. All right, so now I'm just going to go ahead and change everything back. And as you can see, when I save those changes, the reference reappears. So now these two names are linked again, and everything is good in our world. And now I can show you some more features. Something I find really useful is this feature to automatically resolve imports. So if I start using a new function, let's say I do something like clojure.walk / keywordize keys of a b. Then you can see LSP mode gives this little squiggly line here because it's not technically required. So if I want to require it, I can just do LSP Clojure add missing libspec, and it'll add it to inside of my import statements. Now, something that's really annoying is every once in a while, it'll mangle one of the namespace import definitions. I'm not really sure what this is or why it happens, and it doesn't happen very often, but it's one of those things that's just a little bit frustrating because I feel like I sometimes have to double check what happened after I ran one of these commands. And that doesn't really give me the feeling of kind of getting rid of the mental effort. Another thing that's cool, and I know that you probably saw this before, is that LSP gives you code completion for all of your variables. So if you want to go ahead and do, let's say, clojure.walk, and you just start typing, it'll show you all of the variables and all of the function names that are available in that namespace. So I can kind of arrow key down through it and see what's around. Now, this is another one of those features that's really useful most of the time, but often it like messes up a little bit or does something that you don't really expect, and it kind of interrupts the flow of what you're doing. So for example, let's say I'm inside of a clj.s file and I go and I try to make a new comment block. The autocomplete for Clojure script tries to suggest the function clojure.core/complement. And so if you just go ahead and try to create a new comment block and hit enter, it'll actually change what you've written to the complement function instead, which is almost never what you actually wanted. And the reason for this actually is if you take the first three and the last four letters of the string complement, it contains the word comment. So whatever regex matching that they do matches the string comment into this function, even though in context, it's pretty much never what you actually wanted. You can also use LSP mode to move things around in between files. So let's say I have a new variable f that has a value of 1 and I use it somewhere. Then if I want to move this definition around, I can just go and highlight this block of text and do LSP Clojure move form and hit enter and tell it where I want to move the form to. And then it will move this form into this file. But then importantly, it will also update the reference so that this F points to the F that was defined in the right place. So this is really nice. This is really useful for kind of opening up your code and moving stuff around. But yet again, it doesn't always work right. So let me just try, for example, to move this form into this file. I get an error message saying, I don't know if you could read it. Let me open up the messages buffer. But I get an error message saying LSP workspace command execute, nothing to change. So I don't know what this is or why it happens. Maybe somebody with more expertise than me can help explain it. But I run into this a lot, and kind of often the operations that I want to do would be amazing if it worked, but it doesn't always work, and I don't feel like I can mentally kind of rely on it. They also have a bunch of other cool visual tools like LSP Tremax symbols, which basically shows you kind of like just like a nice little list of all of the symbols and variables that are defined in your file, kind of like on a little sidebar view. And they have a whole bunch of other like visual tools and displays or like different ways to kind of look at your code. But in practice, I don't really use these too much. I don't know. I think for a lot of these tools, they like, I open them up and they feel cool, but then I don't really like get like meaningful value out of them. But that's just me. All right, so now I want to talk about a different tool, clj refactor. And this is really interesting because it's actually a completely different style of tool. It's not built on LSP-mode or really clj-kondo, but basically what it does is it uses the currently evaluated state of your program from Cider to understand where things are in your code and to make changes. So in order to even use it, obviously you have to have the package installed and you have to have Cider up and running. And so I'm going to go ahead and evaluate this entire workspace file. And now if I go ahead and I jump to definition, I can see that it points me to the right place. But what's really interesting is that if I go ahead and I modify this buffer, and let's say I even save it, and then I go back and I call jump to definition again, it actually jumps me to the wrong place in the buffer. And this is actually the line number of where the definition was before I added those new lines to my file. So the references will actually point you to the wrong place until I go ahead and I reevaluate this code. And then once I reevaluate it, it goes to the right place again. And what's happening here is as you evaluate your code into Cider, it's evaluating this block of code, but it's also sending Cider a bunch of metadata about where the code was evaluated and what happened. So kind of only once you actually evaluate the code is when Cider knows about it and can kind of pass on that metadata information into all of the refactoring tools. So clj refactor has a whole bunch of different refactoring tools, and there's a lot of overlap with the tools that already exist in LSP mode. So, I'm not going to cover every single feature for the sake of brevity. But one of the features that I use the most often is this function, cljr rename file. And basically what this does is takes a file, the file that you're currently in, you give a new path for that file, and it moves it to the right place. And something really interesting that you'll see here, and I really just kind of want to point this out because it's a good illustration of the way that cljr refactor actually works, is it needs to evaluate your entire project to perform this operation. So like it can only do these types of operations after actually evaluating all of your code. So I'm going to go ahead and hit yes, and then hit yes. And then it renamed my file. And now if I go back inside of run web server, you can see that it also correctly updated all of the import statements. So everything works well. And weirdly, this is one of those things where like LSP mode does sort of have tools to do this, but for whatever reason, I found that the cljr refactor tools for this are just much more reliable. I don't know why. LSP mode move form usually works pretty well, but for some reason LSP really struggles with like moving files around and kind of making these larger structural changes. And I don't know why that is, but I think they're working on making it better, and hopefully it will continue to improve. So kind of what I do for my own workflow is I use LSP mode most of the time. And when things don't work well, or it's kind of giving me trouble, then I switch to cljr refactor, and then I use pretty much the same tool there. And so just like overall, even though there are a lot of really awesome tools made by a lot of really awesome hardworking people, for me, the experience as a developer just like isn't good enough. In order for me to really benefit fully from the power of refactoring, I need tools that can remove the mental overhead so that I don't have to think about what I'm doing or double check its correctness. I can just do operations and count on them and trust that they're going to work. This is the experience that I remember having back in the Java ecosystem, although it's not quite a fair comparison because Java is statically typed and a lot less flexible overall as a language, so it's harder to build refactoring tools for Clojure. Even these kind of fundamentally simple problems of tracking references and figuring out whether two variables are used in the same place is trivial, or at least very, very doable in a language like Java, but much trickier in a language with so much dynamic potential. Another major pain point of mine is the way that Clojure uses single keyword field access to get the value of a field inside of a Clojure record. So without having strong type information, this makes updating the field name of a record almost impossible to refactor programmatically. Now, you might say just use Clojure multi-methods with Molly schema-backed maps. But multi-methods are missing key tools from the Clojure records ecosystem, like the ability to define interfaces and really clamp down and make sure that when I define a new object type, I can statically analyze and verify that I've implemented all of the multi-methods that need to be defined for that new type. For this purpose, I think it'd be really nice if Clojure had some sort of optional static typing, like some sort of way where if you wanted to, you could really clamp things down in a way that made it possible to run certain refactoring operations in a really precise manner. Interestingly, there already are a lot of tools in the Clojure ecosystem to address static typing, but most of them are focused on runtime validation, like Schema, Spec, and Molly. But the main tool for a complete type system, typed Clojure, is once again one of these tools that has a lot of really good ideas and is kind of 90% of the way there, but it's just not good enough in terms of documentation, user experience, and overall just like ease of use to be really useful at kind of tackling some of these refactoring problems. What I really want is I really want a tool that's simple, that plays well with the existing developer toolchain and ecosystem, that really focuses on the gradual nature of a gradually typed type system, and really just a small number of operations that I know that it can do super well and super consistently, and can really explain when I can or cannot apply them. But that's a topic for another video. Last up, I'd like to talk a little bit about clj-kondo, because it's usually the library that you interact with if you want to make changes or improvements to any of your refactoring tools. Remember that clj-kondo is kind of the base level entry point of the entire ecosystem. So it's the tool that all of the other tools are built off of. And so if you have a project and you want to write some custom clj-kondo code, you would go inside of your project and then .clj-kondo, and then I'm going to open up my config.edn, and I can do things here like describe to clj-kondo how to correctly process macros that are defined in my code. And this is really important for correctly tracking references and stuff like that if you have your own custom macro definitions. I won't go through all of the features of clj-kondo here, but something that's really awesome is it's easy to write your own custom linters and tools that run on top of clj-kondo to really kind of give that extra level of organization and stability. It's a really, really awesome tool if you want to do things like enforce owners or custom visibility rules and really start to do some of the team management and organizational things that you need as you start to manage a project at scale. Of all of the tools mentioned here, I think that clj-kondo is the most mature and the most kind of complete and well-adopted ecosystem. And I personally have just had really good experiences working with it and on top of it. Last up, I just want to talk quickly about cursive, which is interesting because it's an editor that runs on an entirely different toolchain than the toolchain of clj-kondo plus LSP-mode. Unlike the other editors, it is a paid platform that you need to purchase and pay real money to use. But it takes a fundamentally different approach because it's built on the IntelliJ ecosystem. This means that it adds Clojure refactoring as a layer on top of the existing Java refactoring tools, which means that the whole ecosystem just works on a fundamentally different mechanism. And it also does an especially good job of handling combined Clojure and Java projects because it integrates more tightly with the standard Java editing tools. Overall, word on the street is that the standard Emacs, Vim, VS Code are pretty comparable to cursive, especially with the major improvements to the VS Code ecosystem in the past couple of years. I don't use cursive myself, so this is really just a summary of information that I've heard from other people. But I personally wouldn't use it over other free and open source tools, unless I had a really strong need to work on some deeply integrated Java projects. Alright, so this is the existing Clojure refactoring system and how it works. Especially when comparing to other languages, I don't think it's quite good enough. But when we're passing judgment, we should make sure to remember that these are all tools often built by just a few people working tirelessly in their free time to make things better for everyone else. They're all fantastic people doing an incredible job with the resources and the time constraints that they have. And they're also the people that are actually out there doing the work and trying to make things better. And so if I could leave this video with one message, it would be to encourage you all to help those people and to help improve those tools and to make the ecosystem better for everyone else. Anyway, thanks so much for watching. If you enjoyed this video, give it a like, subscribe to the channel, and I'll see you in the next one.